Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. In honor of Pride Month, I thought we'd program a little Turing machine-inspired puzzle. You probably know that Alan Turing was a mathematician in the first half of the 20th century who is considered the father of theoretical computer science. I learned about Turing in my theory classes in college. You may have learned about Turing from the movie The Imitation Game. If so, you may know him as the person who invented a machine that could decrypt messages encrypted by Nazi Germany's Enigma machine, saving an estimated 14 million lives. I didn't know any of that about Turing when I was in college because it hadn't been completely declassified. But you may also know that Turing was gay and was persecuted for being gay and died, possibly by suicide, possibly as a result of the appalling and inhumane way he was treated because he was gay. If that makes you angry, it should. Now, I'm going to reference my college theory text called Elements of the Theory of Computation by Lewis and Papadimitriou when I describe a model of a Turing machine. A Turing machine is a theoretical construct. I will put chapters in the video so you can skip this part if you already know what a Turing machine is. But a Turing machine, besides allowing us to simulate any computer algorithm, has important properties that are relevant to learning computer programming, which is why I think a puzzle or game based on Turing machines might be a useful sort of educational game. Not necessarily the one I'm going to create. This is just an homage to Turing today. And maybe somebody's already created a game like this. I don't know. Tell me what you think in the comments. Alright, so a Turing machine has states. Sound familiar based on the ideas I've tried to drive home previously? It has a state, and then it has a tape with a read-write head that can move in both directions. It can read only one location of the tape at a time, and it can move only one space to the left or right of the space it's currently reading. And then it has basically a table of rules. In any particular state, given what it's reading on the tape at this time, what it can do. What it can do is change state, and then either move the control head or write a symbol. As an example, I'm going to show you example 4.1.1 from the Lewis Papadimitriou book. Then I'll talk about the puzzle I want to create based on this, and then we'll program one puzzle. A Turing machine is defined as a set of states, and the machine always has a halt state. A Turing machine has a set of symbols called the alphabet, including the blank symbol $, and then it also recognizes L and R, meaning to move one symbol to the left or one symbol to the right on the tape. Because those symbols have special meaning, they can't be part of the alphabet. Kind of like how you can't name a variable with a keyword. It has an initial state, which has to be one of its states, and then it has the table of transformations. This is a function referred to as delta. The inputs to the function are the states and symbols, and the output is the state and then either the symbol that will be written or an L or R, meaning the read-write head will move either left or right. The machine starts reading at the left end of the tape. For this example, the machine has two states, Q0 and Q1. Its alphabet consists simply of the letter A and the blank symbol $, and its start state is Q0. Its delta table is as follows. Now, because there are two states and two symbols in the alphabet, there are 4 combinations of inputs for which the function must be defined. For state Q0 and A, in other words, reading an A on the tape, the machine should transition to state Q1 and should write blank. For being in state Q0 and seeing a blank, the machine should halt. For state Q1, if the machine sees an A, it should transition to state Q0 and write an A. If it's in state Q1 and it reads a blank, it should transition to Q0 and move right. So imagine a tape that has A blank. From Q0, reading an A, we transition to Q1 and write a blank where the A was. Now in Q1, looking at a blank as the machine now is, it moves back to Q0 and advances one to the right on the tape. So now we're back in the same situation as before, looking at an A in Q0, which means erase it, write the blank, and transition to Q1. Now in Q1, looking at a blank, we go back to Q0 and advance one to the right on the tape. Now we're looking at the last A, so we write a blank and move to state Q1. And now we're looking at a blank, so we transition to Q0 and move one to the right. Now we're in Q0 and looking at a blank. And in this case, we halt and write a blank. I'm thinking for a puzzle, we could present the player with the alphabet, the states, and the tape, and tell them what the algorithm should do, but then have them write delta, the function. We'll list out all of the states they need to define, but they'll have to put the correct states in to get the algorithm to function. I don't know, maybe that would be fun and maybe it wouldn't. So here I've written a very simple little Turing machine. Let's go through it, and then we'll create a puzzle with it in Pygame. This is pretty straightforward. I made it a class, but it's not especially object-oriented. The Turing machine object has an alphabet, which is a list of strings, a state, which is a list of strings, a start state, which is a string, and its delta function is a dictionary in which the key is a tuple consisting of state and then symbol, and its value is a tuple consisting of state and then a symbol which could be a letter in the alphabet or R or L. And then run takes a tape as input. A tape is a list of strings, and it transitions from state to state using the dictionary. The only real wrinkle in that is that the symbol could be L, R, or a symbol to write to the tape, so we need an if statement to check what the symbol is and set the reading head's location appropriately. It prints to the console as it transitions. There's almost no error checking here, but I do check that we don't move off the left of the tape. There's really no point to giving it the alphabet except for error checking, but we're not doing that. In the global space, I create a Turing machine from the example and run it on the tape #. And you can see when it runs, it describes each transition, and in the end, it prints out the final tape. This Turing machine erases a tape of A's. Okay. Now I've created a theoretical all-text Turing machine for the puzzle I want to implement with Pygame. You can see this Turing machine has 3 states besides halt, red house, orange house, and yellow house. But ultimately, what I would want in the final puzzle is a state for each color of the pride flag. We're going to start with these 3 states plus halt because I don't want an overwhelming transition function. And I'm just going to run the program. And you can see that no matter how we start out, whatever the order of colors or whether they're all blank, we end up with a tape that's ordered red, orange, yellow. So the idea is, will our person playing the game be able to write the rules so the flag has the colors in the correct order when the program is done running? That's the puzzle. Now, I've also written the graphical version using the same puzzle. This is not a puzzle engine. I've just written this one puzzle, like one level of a game, and an incomplete one at that. But I thought you might like this because I'm doing something I haven't done before. I'm using a GUI library called pygame-gui. I want to thank Dan Lawrence for creating this library. I know my game programming students are going to love the ability to use these GUI controls in their games. You can install this library using pip, so pip install pygame_GUI. So I'm running it, and I know this is not beautiful. I slapped a background in here so it wouldn't be too stark, but this is very quick and dirty. This is the same puzzle we just saw in the text version. I've tried to represent the states roughly the way they're represented in my theory book, and also the graphic I was showing earlier from Wikimedia Commons. To the right is the tape with a little triangle indicating the tape head. And then I've got a button control below that. Now this is a mix of Pygame sprites and the pygame-gui controls. So the state is a sprite and the tape is a sprite, but the step button is a pygame-gui UI button. The lower tray on the screen is the delta function. All of the states and symbols are enumerated. There are 12 total, and this is a sprite. But within the sprite, there are 24 pull-down menus. This is so the user can create the delta function, which is the puzzle. Can the user create the correct transitions so that we end up with a rainbow on the tape, no matter how it starts? Now, unfortunately, this isn't much of a puzzle. I only have one tape, so they can make an incorrect delta and still get this to work. And I don't freeze the table once they start stepping through, so they can change the table in real time, which is cheating. But I'll create the proper table by selecting from these pull-downs. Okay, and now I'm going to press the step button until we're in the halt state. Now, I'll upload this code to my GitHub repository. I'm not going to go through all of it, but I'll focus on the pygame-gui code and how I integrated it with my sprites and the regular event handling and drawing. At the top, I'm importing both pygame and pygame-gui. And then I have this import on line 6 from pygame-gui.core import object ID. This is so we can attach theming to the UI elements. The only theming I have in this program is an image for the step button. If you want a button with an image, you need to do that through theming. Now, the puzzle table is the delta function that's in the lower tray of the game window. And this is a sprite that incorporates UI drop-down menus from pygame-gui. So we'll just look at how that works. Notice that one of the parameters to the init is of type pygame_gui.UI manager. You'll create one of these objects to manage the GUI components. I create that down in the main program. So here, I'm building this table with a nested loop. I'm looping over the states and then looping over the symbols. You can see that in the text part of this table. But then I'm creating the two drop-down menus to the right. One for the states and one for the symbols. Now I'm keeping those menus in a list so I can construct the user's delta function by getting the values from them. That's the lists I'm appending them to self.states GUI choices and self.symbols GUI choices. But creating them is straightforward. Just invoke the constructor, passing in the list of elements, the starting element, where it should be located, and the manager, so it can register itself with the manager. At least, I assume that's what it's doing. Now, down in Update, I'm iterating through the two lists of menus and pulling out the user's choice using the selected option field, and I'm constructing a dictionary for the delta function, just as I did in the text program. A dictionary seems the most useful way to store that function. Now, below this, I have the state sprite, which is really quite simple, and the tape sprite, which is almost equally simple. In main, on line 257, I'm creating the UI manager. It needs to know the size of the screen, and I'm also passing in the themes JSON. That's really quite simple. It's just the image. I should create some different images for the states of the button, hovered, selected, and disabled, but I haven't done that yet. One thing I want to note is that when I used just button, the pull-down menus also picked up the theme. That's why I gave my button a class at control button, and then the image only applies to my button and not my pull-down menus. I didn't investigate why that was happening. I just kludged a fix in there. You should not put a fix in you don't understand. Well, I understand the fix, but I don't know why the original problem was happening. But this is not production code, it's just for fun, and I'm confident I can figure it out if I investigate. However, if you're familiar with this library and you know why, please tell me in the comments. After creating the manager, I then create my sprites. I need to create the manager before the puzzle table sprite because I need to pass it in, remember, for the drop-down menus. I put the sprites in a group. Now here, I'm creating the step button. And you can see I'm giving it a rect and no text because I'm going to use that image, giving it a reference to the manager and a tooltip that you do see if you hover over it. And then here's that object ID that allows me to connect it to the theme. Now, in my event processing loop, we can check for events in the UI elements. I'm not checking for the drop-downs here because I don't need to respond to those. Every time the puzzle table updates, it builds the user's delta function from the current state of the controls. It accesses them directly. I don't try to change the delta function when an individual pull-down is changed. However, I am responding to the button press by getting the current color on the tape, the current state, and then asking the puzzle table what to do based on the delta function the user has created. So it will return the new state and the new symbol. Remember that the possibilities are move right, move left, or write a color. So we handle those three separately. Right now, the only error checking is I print error to the console if the user tried to move left or right off the tape. Technically, the tape should be infinite to the right, but ours isn't. And then if the new state is halt, I print finished to the console. We need a lot more buttons like reset or new puzzle, new tape, etc. So for now, it just prints to the console. After this, we need to let the UI manager process events, so we send it the event. This is so it can manage the behavior of the controls, such as opening and selecting from a drop-down menu. Now, one little bit of code you'll want to include as well is this calculation of time delta up on line 282. And you'll want to pass that into the manager's update method. I copied that code directly from the examples on the website. The documentation says, we need this time delta value because several of the UI elements make use of timers, and this is a convenient place to get it. Now, one thing that you seem to have to do is blit the background. I tried removing that, and the bottom drop-down menus did not get erased once I'd released them. So I give everything an update and clear, and then blit the background, so I guess I don't actually need the clear. And then I draw my sprites, and then I send draw UI to the manager. Even though the drop-down menus are part of the puzzle table sprite, they're not within its image. They're on the screen. So they need to draw after the sprite draws. And that's it. It's a pretty straightforward app, and it was very easy to combine Pygame and pygame-gui. So a shout out again to Dan Lawrence, who of course has no idea I'm shouting out, but I wanted to express my gratitude for this library. And I hope you found the Turing theme fun and interesting. Remember to embrace diversity. You'll live a richer and happier life. And as always, have fun and keep coding.